Good morning, friends. So now we'll discuss about the loco switching system. We are using direct switch. That means when there is loco is not energized, we have to switch on the baby compressor to raise the pen tool. But when the loco will work on the part circuit, that means 25 kV side will energize. At that time, we will use electromagnetic switch or electro-pneumatic switch, because we cannot work directly on the part circuit. It is high voltage, high current system, so it will be indirectly operated. So here one of the system is electromagnetic switch. That means like ZPT, it is for pento graph, for front pento, reverse pento, or pento. Both the pento option was earlier, or it will be in de-energized condition. There is a 4 positions, but how it will be, how it will work: forward pento, reverse pento, and the both the pento or de-energized pento. What we have done, we have taken a 110 volt DC controlled circuit. From there, we have provided a switch to the positive and connected to a electromagnet. The negative also connected directly, but the positive side is connected through a switch. Another thing is the electromagnet will pull the magnet, and a two contact will make through delay contact type, and it will bridge these two contact and send feed to the auxiliary part circuit. That means auxiliary part circuit will be on. Auxiliary part circuit will be on, but when the pin loco will energize, we need, before that we need this auxiliary power circuit to energize, so that after energizing the loco directly, 5 auxiliaries will work and the rest with the operation of the switch. Yesterday I have told you. So this preparation before energizing the loco we should make through. So see how it works, this auxiliary contact, how it works. Okay. So after closing the battery switch, the electromagnet is energized. The magnet is energized, and it will pull the plunger. It will pull the plunger to make the contact of ZPT. See how. Good afternoon, friends. In the figure, here we have shown how the power supply taken by the motor of the auxiliaries. Arno is supplying the 3-phase supply, and with the application of electromagnetic contactor, we are giving power supply to the auxiliary motors, and when it will get power supply, it will rotate and build up compressed air, and according to the its design, like there are 3 compressors, 2 MPV, then so many exhausters, blower, sorry, not exhauster, blowers for cooling the traction motor, the silicon rectifier block, the transformer oil. The transformer oil circulation is a pump, that is MPH. But all these motors are getting supply from the Arno, the three-phase supply, and with electromechanical electromagnetic contactor, we are closing the switch and giving power supply to it. See how. So we have seen that after closing the switch of the battery, the magnet is getting energized. It pulls the contactors. It makes three contactors, and each contact is provided with red, with yellow, and with the blue chronically from Arno converter. And when this switch will be closed, then the power will fed to the induction motor, three-phase induction motor, and it will start rotate. It will start rotate and build up the compressed air for compressor. There are three compressors, then two exhausters. It will create exhaust vacuum. It will create vacuum. Then your blower motors, like traction motor blower motors, silicon rectifier blower motors, transformer oil cooling blower motors, transformer oil pump. So many auxiliaries. There are 13 auxiliaries they have shown, but nowadays this exhauster is not required almost. This is because our system is now air brake. We need compressed air pressure, and it will prepare the compressed air for electro pneumatic operation. Here it is electromagnetic operation. Another thing is electro pneumatic. That means the same action, the magnet will pull the plunger and it will open a port, and compressed air pressure will admit, and it will press a piston and it will close the contact. But why this? Because we cannot work directly with the part circuit. It is a high voltage part circuit. We will get shock. So this controlling circuit with 110 volt DC we have used here. This is the system. And in traction distribution, what we have done, we are using electromagnetic. That means circuit breaker, the relays. What in relays, what we have done, we have avoided the direct working with high voltage power system with the current transformer and potential transformer by stepping down the current or voltage with minimum wattage, and it is going to the relay. Not you can tell wattage or volt ampere. For transformer better to use volt ampere. The current transformer and voltage transformer is having little volt ampere. Though our system is near about 40 MVA or 42 MVA, but from there we are taking only 60 volt ampere or 100 volt ampere. You think how many little power we are taking for the relays and protection system and metering system. Like our domestic system, the transformer is having more kVA, but we don't need it. We are using 100 watt bulb, we are using 10 watt bulb, 60 watt fan, so it will absorb that thing. Though the transformer may be 100 volt ampere, 100 kilovolt ampere, but we are taking only 10, 100, 60, this type of wattage we are absorbing from the transformer. Transformer is having huge capacity to feed the all loads, which is connected parallel between phase and neutral. In our traction system also, between OHE and the neutral track, there are so many locos, and loco is having huge power. So the loco is taking, one loco is taking say 150 ampere, and our transformer can supply up to 1200 to 1600 ampere normally. So you think if one loco is taking 1500, that means 10 times this system we can use. So this is the system. What is the conclusion? When we will work with the power circuit, we cannot work in the power circuit directly, and we are using control circuit. Mainly it is 110 volt DC or 220 volt DC. In state electricity board, it is also, you can see that 220 volt DC. Battery is having ampere hour capacity sufficient to feed the load of the DC circuit, and also we are having rectifier block as battery charger. When the battery will not be charged, it will feed the DC load. DC load, if it will fail, then another protection we have used, capacitor tripping device. That means capacitor will discharge to energize the circuit breaker trip coil, and the circuit breaker will open once. So many things we have done. If DC is not live, that means if you lose your control, then you may be damaged or dead, or accident may occur. So controlling is the main. So our power circuit is controlled by 110 volt DC or 220 volt DC. In locomotive also there are 110 volt DC. In our traction system we are using 55 cells. Each cell is 5 volt. And in locomotive we are using rectifier block. It is converting AC to DC, and battery is also available to feed for a particular moment the baby compressor to raise the pantograph. Before energizing the loco, the baby compressor will run the baby compressor to prepare compressed air to raise the pantograph only. But it will not allow to operate electrochemical operation. For this we are using 3 compressors. So this is the system. Thank you friend today up to this.